the divisibility test. Divisibility test. Hello and welcome. In this lesson, I'm going to teach you a skill that you can use to know whether a certain number is divisible by either 2, 3, 4, 5, and so on, all the way up to 11. Because I'm sure one of the problems we have encountered in the last lesson was knowing whether this number is divisible by this number exactly without a remainder, so that we can be able to express it as a prime factor of a given number. Because in the last example, we were supposed to express certain composite numbers as products of prime numbers. Especially, this problem occurs when the numbers given, the composite numbers which are given, are very large. And you might want to run a few tests before you can know whether it is divisible by this number or not. So in this lesson, we want to look at the divisibility test for various numbers. And we are going to start with the divisibility test of number 2. Now, we have already looked at this. A number is divisible by 2 if the last digit is even or 0. Let me just go through it because this forms part of the learning. For example, I'm simply going to use 12. We want to know whether this number is divisible by 2 or not. We just need to look at the last digit here. This last digit. We ask ourselves, is that digit even or is it 0? Like, for example, if we are given 120, for example, we look at this last digit, or 30, this last digit, or 74. We look at this last digit. That is what we mean by looking at the last digit of a number. So let's start. We are going to look at the last digit of this number. Is it even? What are even numbers? If we look at the counting numbers, let me just list the counting numbers here. We have 1, we have 2, we have 3, we have 4, 5, 6, 7, 8, 9, and of course 10. There, because of that is 0. So let's look at the even numbers. The even numbers comprise of 2, 4, 6, 8, and of course, if we continue like that, 10 and so forth. But if we limit ourselves to the numbers between 0 and 10, so these are the even numbers. An even number will have one of these numbers as the last digit. So 12 is an even number, 120 is an even number, 30 is an even number, 74 is an even number, but 75 is not an even number. How do I identify even numbers? I identify even numbers by looking at the last digit of that number. So when I look at the last digit of 12, it's 2, and 2 is even. When I look at the last digit of 120, 0, and 0 definitely appears 120 because it's got a 0 there. It must be even. 120 must be even. It's not that I'm saying 0 is even. I'm saying 120 itself is even. So to make it simple, are these numbers divisible by 2? Yes. 12 is divisible by 2 because the last digit is even. 120 is divisible by 2 because the last digit is 0. 30 is divisible by 2 because the last digit again is 0. 74 is divisible by 2 because 4 is even. But 75 is not divisible by 2 because the last digit in that number is odd. It's not even. By the way, the other numbers are referred to as odd numbers. Odd numbers. And that is all about the divisibility test for 2 or for number 2. Let's look at the divisibility test for 3. Okay, I didn't look at an example in the previous one because we have already looked at several examples already in the previous lesson. The divisibility test for number 3. A number is divisible by 3 if the sum, let me change the color for that so that for emphasis, a number is divisible by 3 if the sum of its digits is divisible by 3. For example, let's look at an example from our textbook. 1257. We are given a number such as 1257. We want to know if this number is divisible by 3. So we are going to get the sum of its digits. What are the digits? 1, 2, 5, and 7. Let's see. This gives us 15. Yes, it gives us 15. Is 15 divisible by 3? Yes. Since 15 is divisible by 3, exactly without a remainder, because if we divide 15 by 3, we get 5. Since 15 is divisible by 3, then the number 1257 is divisible by 3. And you can run a test in that. You will get 1257. Here we are just running a test. Find out if it is divisible by 3. 3 goes into 12. How many times? 4. 12 times. We have 0. We drop 5 there. 3 goes into 5. How many times? 1. We have 3. We subtract to get 2. 27. 3 goes into 27 9 times. And you can see this number 1257 is divisible by 3. But do we have to carry out the long multiplication like this in order to know that the number is divisible by 3? No, we've got a shortcut here. We just need to ask ourselves, if I get those digits, add them up. Whatever I get is referred to as the sum. Is that sum divisible by 3? If it is divisible by 3, then it tells us that this number is also divisible by 3. Let's run the divisibility test for number 4. What is it? Divisibility test for number 4. A number is divisible by 4 if its last two digits are both 0 or they form a number which is divisible by 4. Let's have a look at an example again in our textbook. We've got the divisibility test for 4. We've got the example of 1132. We want to test whether this 1132 is divisible by 4. Exactly. Is it divisible by 4? Let's run this test. Let's look at the last two digits. What are they? 32. So we look at 32 because they are the last two digits. Okay, they are not 0. So since they are non-zero, we look at them as they are. The last two digits, do they form a number which is divisible by 4? Is 32 divisible by 4? Yes. I divide 32 by 4, I get 8. And definitely 1132 is divisible by 4. So let's run the test. we want to divide 1132 by 4. 4 goes into 11 2 times because of 8. Then I have 3. I drop this 3 here, and I have 8 here because of 32. And then I drop 1, I drop 2, and 4 goes into 12 3 times to give me 12, and I have 0. And I can see that this 1132 is divisible by 4 exactly, without a remainder. So 4 is a factor of 1132. So instead again of running through this long division method, all you need to do is to look at the last 2 digits. Do they form a number which is divisible by 4? If they do, then that number is divisible by 4. Let's look at the second condition of the divisibility test. We've got 34,700. How about a number such as 34,700? Let's look at its last 4 digits. So we are wondering, is this number divisible by 4? So we look at the last 2 digits. They are 0. They are both 0. So this number must be divisible by 4. Let's test it out. 3, 4, 700 divided by 4. 4 goes into 34 8 times because of 32. I subtract 2, I drop 7. 4 goes into 27, I think 7 times. No, 6 times. 6 times because of 24. Then I have 3. Then I drop the first 0. 4 goes here 8 times because of 32. No, I think it is 7 times. Let me correct that because of 28. 4 goes into 30 7 times because of 28. And then when I subtract here, I get 2. And when I drop the last 0, I find that 4 goes into 20 exactly 5 times to get 20. And I subtract, I get 0. So 4 is a factor of this number. But do I have to go through all this process in order to know? No. All I need to do is have a look at the last 2 digits. If they are both 0, then that number is automatically divisible by 4. If the last 2 digits, they form a number which is divisible by 4, so I just need to test this last digit. If it is divisible by 4, then I know the whole of that number is divisible by 4. I hope that one is clear. Let's look at the divisibility test for 5. This is one of the simplest, so we won't waste much time here because we also looked at it in our last example. The divisibility test for 5 is as follows. If the last digit is 5 or 0, then that number is divisible by 5. Let's see. 215, for example. Let me change the color for the pen. 215. We want to know, is 215 divisible by 5? We just need to look at this last digit. If the last digit is 5, then it is divisible by 5. And indeed, any number is divisible. Any number with the last digit being 5, starting from 5, we go to 15, we go to 25, 35, 45, and so forth. Those numbers are divisible by 5. 5 is a factor of those numbers. How about if it has 0? Let's start with 10. 10 is divisible by 5 because 5 goes into 10 twice. 20 is divisible by 5, 30 is divisible by 5, and so forth. It is one of the simplest divisibility tests that is out there other than 2. So a number is divisible by 5 if the last digit is 5 or 0. Here it is 5. Let's look at a number with 0 at the end. Is it divisible by 5? Exactly, because it's got a 0 at the end. It must be divisible by 5 because whatever number we'll be remaining with will either be 10, 20, 30, 40, 50, and those numbers are divisible by 5. Let's run the test for this. We have 20 here, we have 50 there, and we've got 5 here. 5 goes into 20 4 times because of 20. We have 0, we drop 5. 5 goes into 5 once in order to get 5, 0, and then we drop this other 0. 5 goes into this, let me see, 0 times. That will be 410. So instead of running this long multiplication method or division method, the best we can do is to just run this test. Is the last digit 5 or 0? Then if that is the case, then that number is divisible by 5 and divisible by 5. Very simple test. Let's run the next one. Divisibility test for number 6. How do we know that a number is divisible by 6? This is how we know that a number is divisible by 6. What do we do? If it's divisible by 6, then it must be divisible by both 2 and 3. What does it mean that it must be divisible by both 2 and 3? It means we get that number, we check whether it is divisible by 2, and we know the divisibility test for 2. And then we check the same number whether it is divisible by 3, and we know the divisibility test for number 3. Let's have a look at an example. Again, I want to look at an example which is given in your course book. I want to look at the example of 612. So we want to test, is 612 divisible by 6? What is the first test? Is it divisible by 2? What is the divisibility test for 2? A number is divisible by 2 if it is even, or if the last digit is even, or the last digit is 0. Does it fulfill that condition? Of course it does. Let's run the other one, 612. Is it divisible by 3? What did we say is the divisibility test for 3? We get the sum of its digits. 6 plus 1 plus 2 is 9. Is 9 divisible by 3? Of course it is. So this number is divisible by 3. Now, since this number is divisible by both 2 and 3, then it must be divisible by 6. 612 divided by 6. We run that test, get 612. We divide by 6. 6 goes into 6 once because of 6. Subtract there, I get 0. I drop 1. I get 0. I drop 2. I get 2. So 102 is the answer over here. So it is indeed divisible by 6. This one is a proof for this one here. We can get a number which is not divisible by 6. Like, for example, let me look at the next number, 613. Now, is it divisible by 2? Exactly? No. So 2 is not a factor of that. And once one of them fails, the other one, even if it works or it fails, then still it must be, we must obey this condition here. You must test for both numbers. You know, one of them can work, like for example 614. Is it divisible by 2? Yes. But is 614 divisible by 3, for example? Let's check. 4 plus 6 is 10 plus 11 is 11. 11 divided by 3? It's not. So, while one of them numbers may work, 614 divided by 2 is possible. So 2 is a factor of 614. But when we test for 3, we find that it fails. That means when we get this number 614, we try to divide it by 6, then it will fail. It will fail. You know, these tests are like this. When we say 612 is divisible by both this and that, then we put a 2 here and we put a 3 here. You see, when we multiply 2 and 3, we get 6. So it's like we are getting 612 divided by 6, which is a product of these two. So long as we can break down this number into its prime numbers, then we test for one of them, we test for the other one, then definitely that number is divisible by this number whose prime factors are these ones. So, but to make it simple, just test. Is it divisible by 2? If that is a tick, don't stop there. Go ahead with the same number. Test whether it is divisible by 3. Remember, the divisibility test for 2 is that the last digit must be even or 0. The divisibility test for 3 is that the sum of its digits, 6 plus 1 plus 2, must be divisible by 3. And that is exactly what we did. I hope we are together so far. Let's run the divisibility test for 8. How do we know that a number is divisible by 8? A number is divisible by 8 if the number formed by its last digits, the number formed by its last 3 digits is divisible by 8. The number formed by its last 3 digits is divisible by 8. So again, let me look at an example here of the divisibility test for number 8. And the example they've given in your course book is 3027144. 3027144. You can see that the number is quite large. We want to find out, is it divisible by 8? So what is the test? We look at the last 3 digits. These are the ones. The number formed is 144. So we just need to test whether 144 is divisible by 8. It goes here once because of 8, 64, 64, 8 goes into 64 8 times. And indeed, 144 is divisible by 8. So this large number here must be divisible by 8. And you can test that one all by yourself by doing the long division method. All you need to remember are the tests, are the various tests. So remember, the last 3 digits must be divisible. The number formed by the last 3 digits must be divisible by 8 for the whole of that number to be divisible by 8. Again, you can look at the exercises. The exercises there are very many of them, so do them. Let's look at the divisibility test for number 9. Divisibility test for 9. A number is divisible by 9 if the sum of its digits is divisible by 9. It is like the divisibility test for for number 3, the sum of its last, let me just confirm that, the sum of its digits is divisible by 3. The sum of all its digits is divisible by 3. But here, I think it's a little bit simpler because we are saying the sum of its digits is divisible by 9. While here, it was the sum of its digits divisible by 3. So all we need to do is just add the sum of its digits. Again, let me look at an example. They've given 32, 157. 32, 157 divided by 9. We are wondering, is it divisible by 9? Let's see. So we get the sum of its digits. 3 plus 2 plus 1 plus 5 plus 7. This gives me 10, 18. Is 18 divisible by 9? Of course it is. So this number must be divisible by 9. So it's just like the test for 3. Divisibility test for number 3 states that a number is divisible by 3 if the sum of its digits is divisible by 3. And of course, let's look at the next one, divisibility test for 10. A number is divisible by 10 if the last digit is 0. Of course, you know this from what we've been doing. If you do 20 divided by 10, we usually cancel these zeros and we get 2. That means 10 is a factor of 20. And that number is exactly divisible by 10. Let's check another number, 1000 divided by 10. We've been doing this all through. So a number is divisible by 10 if the last digit is 0. That one is just as simple as that. Let's look at the last divisibility test that we want to look at. So next, let's run the divisibility test for 11. It states that a number is divisible by 11 if the sum of its digits, here there is a word that is if the sum of its digits in the first, third, fifth, and seventh positions, etc., that is the odd positions, and the sum of its digits in the second, fourth, sixth, eighth, 10th, etc., that is the even positions, are equal. So if you compare the sums, you find that that sum is equal to this sum, or they differ by 11, or they differ by a multiple of 11. So let's check one of these, and that is I'm going to look at a number in your example, which is in your exercise 3.9a, where we are supposed to test for 2596. 2596. So we are wondering, is 2596 divisible by 11? So let's look at the first position. What digit do I have in the first position? I have 2. What digit do I have in the third position? Third position, I have 9. This gives me 11. Next, what digit do I have in the second position? I have 5. What digit do I have in the fourth position? I have 6. Again, this is 11. What is the difference between are the two equal? If they are equal, the condition has been fulfilled. Since these two numbers are equal, then this number is exactly divisible by 11. So 11 is a factor of 2596. let's look at another example. The example that I now want to look at is the example that they've given in your course book. The number that we want to test whether it is divisible by 11 is 82, 60, 439. So we want to test 82, 60, 82, 60, 439. 439. So let's check the sum of these digits in the first, third, and fifth positions, because you don't have the seventh, or there is the seventh position. Yeah. So we add 8 plus 4, plus 6 plus 4 plus 9. That is like 14, 18, 27. Then I come and add these ones here. Let me write them in different color. 2, 0, and 3. 2 plus 0 plus 3 is going to give me 5. What is the difference between them? So they are not equal. First of all, they are not equal. The sum of this is not equal to the sum of this. So I check for the difference between them. If I check for the difference, 27 minus 5, I get 22. This number is a multiple of 11. It's a multiple of 11. So since it is a multiple of 11, in other words, if I do 22 divided by 11, I get what? I get 2. It means that the condition has been fulfilled and that this number is divisible by 11. Now I was checking for this one. This number is divisible by 11 and it's correct. So that test is the one which is a little bit longer than the others, but it's not so difficult. You look at the number that is given and then you identify the positions of the various digits. The one in the first position, third, fifth, and seventh. Those are odd number positions. You add those digits together. You put that number aside. Then you look at the digits in the even number positions, like second, fourth, sixth, 8th, 10th, 12th, 14th, and so forth, depending on the size of the number which is given. Again, you add all those digits. You get the first sum, you compare it with the second sum. If the two sums are equal, if they are equal, then that number is divisible by 11. If they are different, then you find the difference between the two sums. If the difference between the two sums gives you 11, then that number is divisible by 11. If the difference between the two numbers gives you a number which is a multiple of 11, that is, it's either 11, it's either 22, 33, 44, 55, 66, all those numbers are multiples of 11. Then you will know that the given number is divisible by 11. So hopefully these divisibility tests are going to help you to get the factors of the prime factors of a given number, because you can see in our last lesson, when the numbers became bigger and bigger, we were just wondering, is this number divisible by 2? Is it divisible by 3? Is it divisible by 4? It will help you to express composite numbers as products of their prime factors. This skill is very, very important. So make sure that you learn each one of these skills, starting from the first one, the first test. If a number is divisible by 2, then you know the last digit is either even or 0. If the number is divisible by 3, then the sum of all its digits must be divisible by 3. Number 4, if a number is divisible by 4, then the last two digits are either both 0 or they form a number which is divisible by 4. The divisibility test for 5, if a number is divisible by 5, then the last digit is either 5 or 0. If a number is divisible by 6, then it is divisible by both 2 and 3. How about 8? If a number is divisible by 8, the number formed by its last 3 digits is divisible by 8. Otherwise, if it is not divisible by 8, the whole of that number is not divisible by 8. How about divisibility by 9? A number is divisible by 9 if the sum of the digits in the number is divisible by 9. It is similar to the divisibility test of 3. How about divisibility test for 10? It is the simplest. If the last digit in the number is 0, then that number is divisible by 10. And of course, the most complicated one that we have just looked at is the divisibility test for 11. But it is not that difficult, because you just need to identify. Look at the number carefully so that you can identify the positions of the following odd positions: 1, 3, 5, 7, 9, 11, and so forth. Those are the odd numbers. So you look at the numbers in those odd positions, and then you add them up. Then you look at the numbers in the even positions, that is 2, 4, 6, 8, 10, 12, and so forth. And then you add them. Once you add them, you compare the two numbers. If they are equal, then, or if the difference between them is 0, which means they are equal, then that number is divisible by 11. If they are different, find the difference between them. If the difference between them is 11, then that number is divisible by 11. If the difference between them is 22, then that number is divisible by 11. If it is 33, the difference between them is 33, then it is divisible by 11. Or, what I'm trying to say, if that number is a multiple of 11, then the number is divisible by 11. So hopefully this one has been of help to you. Go through the whole of the exercises given in chapter 2. Otherwise, that brings us to the end of chapter 2. In the next lesson, we will look at chapter 3, which is on the greatest common divisor. See you in the next lesson.